Hi, welcome to this short tutorial on statics of solid mechanics. My name is Adam Gatogo, and in this short tutorial I will take you through determining the magnitude of the resultant force R of two given forces using cosine and parallelogram law of forces. Thanks for joining me. Given this parallelogram, A, B, C, and D are angles. F1, F2, F1, F2 are also forces, and then the F1 forces are parallel to each other, F2 forces are also parallel to each other, and R is the resultant of F1 and F2 forces. And then angle A and angle C are opposite and equal. Likewise, angle B and angle D, they are also opposite and equal. Angle A is adjacent to angle B and they add up to 180 degrees. So angles here, angle A plus angle B should give you 180 degrees. Likewise, angle B plus angle C, they are also adjacent. So when you add angle B plus angle C, you should get 180 degrees. Now, by cosine law, the magnitude of the resultant force R is given by R squared equals to square of F1 plus square of F2 minus 2 times the product of F1 and F2 cos B. That's the angle between F1 and then F2. Or you use the angle adjacent to the angle between F1 and F2. That's either angle A or C. So when you are considering those angles, the sign has to change to plus, and then you have your expression to be R squared equals to F1 squared plus F2 squared plus 2 times the product of F1 F2 cos angle A or C. Now let's take a look at this question and solve it. Two men, namely Idrisu and Kelvin, are trying to roll the boulder by applying the forces shown. Determine the magnitude of the force that is equivalent to the two applied forces. Now let's say this is Idrisu and Kelvin trying to roll this boulder by applying this 300 Newton force and 150 Newton force. So we've been given 300 Newton force and then 150 Newton force, and we are looking for the magnitude of the force equivalent to the applied force. It's equivalent to this 300 Newton force and then 150 Newton force, and that is the same as finding the resultant of those two forces. Now let's take a look at this diagram and draw a diagram to form a parallelogram out of this particular diagram. So you start with the 150 Newton force, which made an angle of 20 degrees to the horizontal. So the ending point of the 150 Newton force should be the starting point of the 300 Newton force, which also makes 70 degrees to the horizontal. So you also place it there 70 degrees going this way. So the 150 Newton force is going this way. The 300 Newton force is also going this way. So its resultant should also go that way to meet them at this point. And then you draw to form your parallelogram. Now, looking at this angle and then the angle formed here, they are alternate angles. So the 20 degrees here equals the angle formed here. So this angle also formed here is 20 degrees. Now angles on a straight line add up to 180. This is 90. This is 70. So 90 plus 70 is 160. So it means that this small angle here is 20 degrees. Now when you add this 20 plus 90 plus another 20 here, then you get angle, say gamma equals to 130 degrees, and that becomes the angle between F1 and F2 force. And now the angle adjacent to this 130 degrees is this angle. So 50 plus 1 30 should give you 180. So this angle here is 150. Now, by cosine law, R is given by R squared equals to F1 squared plus F2 squared plus 2 times the product of F1, F2 cos alpha. That's angle. Alpha is the angle adjacent to the angle between the two forces. Or you take it that R squared equals to F1 squared plus F2 squared minus 2 times the product of F1, F2 cos gamma, and gamma is the angle between F2 and then F1. That's the 150 Newton force and then the 300 Newton force. Now you carefully slot in your values. R squared equals to the F1 squared, that's 300 Newton squared, plus F2 squared, 150 Newton squared, plus 2 times the F1 times 150 Newton, that's F2 cos 50, the angle adjacent to the angle between the two forces. Then when you do that, you will get 170,350.884. And now you take the square root of both sides, and then you get R to be equal to 402.7359 Newton. Or when you go the other way, that's you use the angle formed between the two forces, then you use your angle gamma. So R squared equals to 300 squared plus 150 squared minus 2 times 300 times 150 cos 130. When you punch your calculator very well, you should get 170,350.8849. Then you take the square root of both sides to get R equals to 412.7359 Newton, and that is how to calculate the magnitude of the resultant of two given forces. Thank you.